Good morning, students. Before watching this video, please make sure that you have watched the previous videos that I have uploaded. So far, 5 videos on this topic parabola has been uploaded. Now, the third A exercise we have started, in which we have completed 2 Romans. Now, the third Roman first problem is find the equation of the parabola whose focus is minus 2, 3 and the directrix is the line given. Also find the length of the lattice rectum and the equation of the axis of the parabola. So the situation is somewhat like this. Since we don't know whether the axis is symmetric about x-axis or y-axis, nothing has been mentioned according to the given information. So therefore, this parabola, for example, I have taken, and this is my principal axis. This is S. So S is the fixed point which is focus is given minus 2, 3. And this is my fixed line which is said to be a directrix. The directrix is the line which is perpendicular to the axis. Now this is L, that is 2x plus 3y minus 4 equals to 0. Now find the equation of the parabola. The parabola equation is what we need to find out. Now this is, to obtain this parabola, let us take P, x1, y1 be any point of the locus of parabola. Solution, let P x1, y1 be any point on the locus of the parabola. So this Z is the foot of the directrix So M, let N, Z be the projections of N is the projection of P. So this is M I will take. So M is the projection of P and Z is the projection of S. Projections of P, S on the M is the projection of P on the directrix and Z is the projection of S on the directrix. P, S on the directrix, L equals to 0. Now, according to the definition of a parabola, so P's distance from the fixed point SP is equals to P's distance from the fixed line PM. SP is equals to PM, where SP is the distance between the 2 points S, P. So this is equals to square root of x1 minus x1 plus 2 whole square plus y1 minus 3 whole square. And PM is, what is PM? PM is the length of the perpendicular of P onto the directrix. PM is the length of the perpendicular or perpendicular distance of P x1, y1 onto the directrix, which is a line. N equals to 0. So therefore, perpendicular distance from P to this line is 2x1 plus 3y1 minus 4y square root of square of the quotient of x 2 square 4 plus square of the quotient of y 3 square 9. So this is SP is equals to SP and PM. If squaring on both sides, SP square is equals to PM square. Now SP square equals to PM square. This is equals to root 13 square is 13. Root 13 square is 13. When it is cross multiplying with this, then we get 13 into x1 plus 2 whole square plus y1 minus 3 whole square is equals to, this is 2x1 plus 3y1 minus 4 whole square. This is equals to 13 into a plus b whole square, x1 square, 2 square 4 plus 2 2s are 4 x1 plus y1 square, 3 square 9 minus 2 3s are 6 y1 is equals to, this is a plus b plus c whole square, a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So 4x1 square plus 9y1 square plus 4 4s are 16 minus plus 2 3s are 6, 6 2s are 12 x1 y1 minus 2 4s are 8, 8 3s are 24 y1 minus 2 4s are 8, 8 2s are 12 x1. This is equals to 13x1 square minus 4x1 square is 9x1 square. Next, this is 12x1 y1. If you transpose on this side, minus 12x1 y1. This is 13y1 square. This is 9y1 square. 13 minus 9 is 4y1 square. Next step. 13 4s 52. This is 52 plus 12 is 64. 4x1. 52x1 plus 12x1 is 64x1. Next, 13 into 6, 78 minus 78. Next here, plus 24, 4, 5. So minus 54 y1. Next, 4 plus 9, 13 13s. 4 plus 9, 13 13s, 169. Here, plus 16. If you transpose on that side, minus 16. This is equals to 153. Is equals to 0. Therefore, the locus of P x1 comma y1 is 9x square minus 12xy plus 4y square plus 64x minus 54y plus 153 equals to 0. Of course, it is not able to be a parabola, but this is the second degree non-homogeneous equation. The condition for the second degree non-homogeneous equation to represent a parabola is h square equals to ab. So where h is equals to here 2hxy, 2h is equals to minus 12, h is equals to minus 6. A is quotient of x square 9, quotient of y square is b, that is 4. So h square minus 6 whole square is 36. 9 fours are 36. 36 equals to 36. Therefore, this is the required equation of the parabola and equation of the axis. Equation of the axis. So, to obtain the equation of this axis and the directrix are mutually perpendicular to each other. Axis and the directrix are mutually perpendicular to each other. So, what is the slope of the directrix L equals to 0 is M is equals to minus A by B minus 2 by 3. Therefore, slope of axis is equals to 3 by 2, perpendicular slope of this. So, since axis is perpendicular to the directrix, therefore here the slope of this line is 3 by 2 and passing through this point. With the help of these two slope or point form, we will obtain the equation of the axis. Now the equation of axis which has the slope which we got right now 3 by 2 and the axis is passing through the point minus 2 comma 3 which is the focus is slope point form. Y minus y1 equals to m into x minus x1 implies y minus this is x1 y1. Y minus 3 equals to the slope of m is 3 by 2 into x minus x1. Minus of minus is plus 2. This is equals to 2y minus 2 3s are 6, 3x 3 2s are 6. Therefore, 3x minus 2y plus 6 plus 6 plus 12 equals to 0 is the equation of the axis. And length of the latus rectum. So this is our S and this is our, let us suppose that P dash. Latus rectum is this. Latus rectum is the line which is parallel to the directrix and perpendicular to the axis. And length of the latus rectum is here. This is 4a. That means this is 2a and this is 2a. And this is the vertex of the parabola. So this is also A and this is also A because foot of the directrix, vertex, focus are collinear points and A is the midpoint of ZS. That is why if AS is small a, ZA is equals to small a. So this is A comma 0, this is minus A comma 0. Now, therefore, this is length of the latus rectum is length of the latus rectum is equals to 4a. 4a can be written as 2 into 2a. So 2 into, what is 2a? 2a is this a plus a. So this is 2a. That is 2a is perpendicular distance of S from L equals to 0. What is this? This is ZS is the perpendicular distance of a point S to the line L equals to 0, of S from L equals to 0. So this is equals to 2 into perpendicular distance from this point to the line, 2 into modulus of 2 into minus 2 plus 3 into 3 minus 4 modulus by square root of 2 square plus this is 3 square. This is equals to 2 into minus 2 minus 4 minus 4 minus 8. 3 3s are 9. 9 minus 8 is 1. So 2 into this is 1 by root 13. That is equals to 2 by root 13 is the length of the latus rectum. Prove that the area of the triangle inscribed in the parabola y square equals to 4ax is, this we need to prove, where y1, y2, y3 are the ordinates. That means y coordinates of its vertices. Let us suppose that this is a parabola. This is our parabola and there are 3 points. Let us suppose this is P, this is Q and this is R. So P x1, y1, Q x2, y2 and R x3, y3. Here y1, y2, y3 are the y coordinates of the 3 points. So with these 3 points, a triangle is formed, and if I join this area of the triangle, we need to prove it to be this. Now let Px1, y1, Qx2, y2 and Rx3, y3 or the vertices of a triangle. Vertices of a triangle PQR. So x1, y1 is the Cartesian points, but whereas the parametric point of them is at1 square 281, at2 square 282, at3 square comma 283. So therefore, area of triangle PQR is equals to half into x1, y1, 1, x2, y2, 1, x3, y3, 1. So this is what we have learned last year in the coordinate geometry. So now this is equals to half x1, y1, x2, y2, x3, y3 are the Cartesian points, but whereas at1 square, so P is equals to at1 square comma 2at1, Q at2 square comma 2at2, R at3 square comma 2at3. So without loss of generality, instead of this Cartesian point, we can take the parametric point as well. So now half into this is at1 square 2at1, 1, at2 square 2at2, 1, at3 square 2at3, 1. This is equals to half into. So here A is common in the first column. So that is equals to half into A is taken common. Not only that, 2A is common in the second column. So A into 2A, if I take a common here, then we are left with T1 square, T1 square, T1, 1. T2 square, T2, 1. T3 square, T3, 1. This is equals to 2 gets cancelled here. This is equals to A square into. Now let us do the operations, row operations as well as column operations. So let us do the column or row operations. This is equals to here. I'll do row 1 minus row 2 and row 1 minus row 3. That is equals to, so row I'll do row 2 is transformed as row 2 minus row 1. Row 3 is transformed as row 3 minus row 1. That is equals to a square into, this is T1 square T1 1. This would not be subjected to any change because row 2 and row 3 are getting changed. So here row 2 minus row 1 is T2 square minus T1 square. Here T2 minus T1, 1 minus 1 is 0. Likewise, row 3 is transformed as row 3 minus row 1, T3 square minus T1 square. Here T3 minus T1, 1 minus 1 is 0. This is equals to a square. Here T1 square T1 1. So this can be written as T2 minus T1 into T2 plus T1. This is equals to T2 minus T1 as usual, and this is 0. Now this is T3 minus T1 into T3 plus T1. A square minus B square, A plus B into A minus B. This is T3 minus T1 and this is 0. This is equals to A square into, here if you see T2 minus T1 is common in the whole second row, because T2 minus T1 if I take common, then we are left with T2 plus T1 here. This is T2 minus T1 into 1. T2 minus T1 taken common, then 1 will be left. Here 0 into T2 minus T1. T2 minus T1 if I take common, then 0. So A square. In the same way here also T3 minus T1 can be taken common. So here A square into, this will be taken common from the second row, and T3 minus T1 in the third row. T3 minus T1. So that is T1 square T1 1. This is T2 plus T1. T2 plus T1 1 0. This is T3 minus T1. So T3 plus T1 1 0. So expanding along R3 we get, so A square into T2 minus T1 into T3 minus T1 into, this is this and this will be taken. So this is T2 plus T1 into 1 is T2 plus T1 minus of 1 into T3 plus T1 is T3 plus T1. This is equals to A square T2 minus T1 into T3 minus T1 into, this is T2 plus T1. T1 gets cancelled. We are left with T2 minus T3. Now this is equals to A square. Here what I am doing is I will multiply with 2A into 2A into 2A. So 2 to the 4, 4 to the 8, 8A cube. 8A cube I will divide also. So dividing and multiplying with 8a cube. Then here we are left with T2 minus T1, T3 minus T1 into T2 minus T3. This is equals to this and this gets cancelled. So we are left with 1 by 8a into 2a T2 minus 2a T1. 2a T2 minus 2a T1 into 2a T3 minus 2a T1 into 2a T2 minus 2a T3. This is equals to 1 by 8a into this is 2a T2 is y2. So y2 minus y1. So 2a T2 is y coordinate. So 2a T2 is the parametric point of, so x1 y1 is the Cartesian coordinate, while 8t1 square comma 2a T1 is the parametric point of the same Cartesian coordinate. So therefore 2a T1 is y1. So this is y1. This is y3 minus y1. This is y2 minus y3. Therefore area is positive always. This can be written as 1 by 8a into, this is y1 minus y2 also we can write into y3 minus y1 into y2 minus y3 is what we are supposed to prove in modulus, because area is always positive. Therefore y2 minus y1 can be written as y1 minus y2 also. Find the coordinates of the vertex, focus and the equation of the directrix or and the axis of the following parabolas. So this is y square plus 4y is equals to minus 4x plus 3. Keep all y terms on one side and the constant and x on the other side. So this is equals to, try to write in a plus b whole square. So y square can be written as y plus 4y is, the quotient of y is 4, half of it is 2, complete the square here, minus 2 square is 4. So this equals to this only, because y square, a square plus b square plus 2ab, y square plus 2 square 4 plus 2 to the 4 y minus 4. So plus 4 minus 4 gets cancelled. We are left with the same thing only. Here is equals to minus 4x plus 3. This is equals to y plus 2 whole square is equals to minus 4x plus 3 plus 4. This is equals to minus 4x, 3 plus 4 is 7. So this is equals to, take minus 4 as a common, then x minus 7 by 4. So this is equals to y plus 2 whole square. This is equals to y minus of minus 2 whole square is equals to minus 4 into x minus 7 by 4. It is of the form. It is of the form y minus k whole square is equals to minus 4a into x minus h. So here 4a minus minus same, in the place of 4a we have 4. So a is equals to 1. Now, so the vertex a is equals to h comma k, because it is not y square equals to 4a minus 4ax type. Here additionally in the place of 0 0 we have minus 2 and 7 by 4. Therefore h comma k is equals to 7 by 4 comma minus 2. So therefore vertex we got, and so this is the vertex we got. Focus focus for y square. So this could be always compared with the standard or simplest form of the parabola. What is the simplest form of the parabola of this? Y square equals to minus 4ax. This is y minus k whole square equals to minus 4a into x minus h. Could be compared with the standard form of the parabola whose vertex is at the origin is y square equals to minus 4ax. For y square equals to 4ax, focus S is equals to 0, 0. Focus vertex S is vertex A is equals to 0, 0. But for this, vertex A is equals to, for y minus k whole square equals to minus 4a into x minus h. For this, vertex A is equals to, for 0, 0, x coordinate is to be added h and y coordinate is to be added k. So h comma k, that is what we have written here. And for this, what is the focus? Focus S is equals to, for y square equals to 4ax, a comma 0. For y square equals to minus 4x, the vertex is minus a comma 0. But for here, this is h comma k. And for this, S is equals to, with the x coordinate, h will be added, with the y coordinate, k will be added. So minus a plus h comma k. Therefore here, S is equals to minus a plus h comma k, minus a is 1 plus h value is 7 by 4 comma the value of k is minus 2. So this is equals to 4 ones are 4 minus 4 plus 7 3. So this is equals to 3 by 4 comma minus 2. So focus also we get equation of the directrix. What is the equation of the directrix? L equals to 0. For y square equals to 4ax, for y square equals to 4ax, this is the y square equals to 4ax parabola. This is a comma 0 and this is minus a comma 0, this. Then this line is parallel to y axis, x equals to minus a. But for this, x equals to plus a. But here x is equals to with a, additionally h will be added. So therefore, equation of the directrix is x is equals to a plus h. So a is 1 plus h is equals to 7 by 4. So 4 ones are 4 plus 7, 11. So this is 11 by 4. That is equals to 11. This is equals to, x is equals to 4x is equals to 11, or 4x minus 11 equals to 0. So equation of the directrix also we get. And equation of the axis. Equation of the axis means principal axis. So the line which is passing through the focus is called the axis. So for y square equals to 4x or y square equals to minus 4x, so this is the axis. What is this? Is the line, is the x-axis. X-axis equation is y equals to 0. But for this, y is equals to k. Y is equals to 0. With this, additionally k will be added. So this is equals to, y is equals to, k is minus 2 here. So this is equals to, y plus 2 equals to 0. So the next question is x square minus 2x plus 4y minus 3 equals to 0. This is the last problem from the exercise 3a. Solution. This is the given equation of the parabola. Given equation of the parabola is this. Now, this is equals to x square minus 2x is equals to minus 4y plus 3. So, keeping all x terms on one side and constant and the y coefficient on the other side. So, this is equals to, so this is to be converted into a minus b whole square. So, x square can be written as x whole square minus 2 into 2x can be written as 2 into x into 1. This is a square minus 2a. This is b. This is b. So, a square minus 2ab plus I want b square. So, here b is what? 1 square. So, this and these are equal, but this 1 square is additionally added. Therefore, minus 1 square also I will subtract, because when 1 square is additionally added, 1 square is to be subtracted so that the equation will be balanced. And now, this is our form a square minus 2ab plus b square. So, this is equals to how much? A minus b whole square. So, this is equals to how much then? This is x minus, this is how much? X minus 1 whole square, because this is a square minus 2ab plus b square. This is a is x, b is 1. So, x minus 1 whole square minus 1 is equals to minus 4y plus 3. This is equals to x minus 1 whole square is equals to minus 4y plus 3 plus 1. This is equals to minus 4y. 3 plus 1 is 4. Take minus 4 as a common. Then I will be left with y minus 1 here. So, this is equals to minus 4 into y minus of 1. This is equals to x minus 1 whole square. So, this is of the form x minus h whole square is equals to minus 4a into y minus k. So, here this is the parabola not in its standard form, because here h comma k are additionally added. So, had it been x square equals to minus 4ay, the vertex would have been 0, 0. In that case, it would be standard form of the parabola. So, here 4a. So, comparing this with this, then minus minus same. In the place of 4a, 4 we have. So, 4a is equals to 4. From this, a is equals to 1. And so, the vertex is represented or denoted by the letter a. A is equals to h comma k. So, here h is 1 comma k is 1. H comma k are 1 comma 1. Now, let us compare. So, x square equals to minus 4ay with that of x square equals to x minus h whole square is equals to minus 4a into y minus k. Okay. This is equals to, for this vertex A is equals to 0, 0. Here the vertex A is h comma k. Focus S is equals to, for x square is equals to 4ay, for x square equals to 4ay, 0 comma a is the vertex. But x square equals to minus 4ay, 0 comma minus a. Here S is equals to, with 0 h will be added, with minus a k will be added. So this is equals to h comma minus a plus k k. Next, equation of the directrix. Equation of the directrix. If you are confusing with the parabola, then actually I will facilitate this for you. So this is the parabola x square equals to minus 4ay, and this is the focus. This is the focus which is 0 comma minus a, which is lying on the downside of y-axis. Therefore 0 comma minus a. On y-axis x coordinate is 0. Since it is negative y-axis, minus a. Now this is a and this is our directrix. This is our directrix. This is 0 comma plus a is this. So since this line is parallel to the x-axis, y equals to something. So y is equals to a is the equation of the directrix for x square equals to minus 4ay. For here, equation of the directrix is y is equals to a plus k would be added with this, and equation of the axis. Equation of axis. What is axis? That line which is passing through the focus. So which line is passing through the focus here? It is y-axis. So what is the equation of y-axis? X equals to 0. But here equation of axis is x is equals to 0. Additionally, h will be added. So this is what we need to find out. So I am rubbing all these things and see this. So already vertex is found and focus. S is equals to h comma minus a plus k. H is equals to 1 minus 1 plus k is equals to how much? 1. So this is equals to 1 comma 0. And equation of the directrix. Equation of the directrix is y is equals to a plus k. A is 1 plus k is 1. So therefore it is y equals to 2 or y minus 2 equals to 0. And equation of the axis is x is equals to h. So implies x is equals to h is here 1. So therefore it is x minus 1 equals to 0.